Alright, in this video we are going to do an optimization problem. This is from Khan Academy. Given f of x equals 4 minus x squared for f of x greater than or equal to 0, a rectangle is constructed with two vertices on the curve, f of x and 2 on the x-axis as shown in the diagram. What is the maximum perimeter of the rectangle? Alright, well here's our rectangle, and let's try to model the perimeter here. So if this point is x comma 0, then this width here is x, which means the width of the length of the bottom is 2x. And my height here, well, since this is on the curve f of x, the height is the y coordinate, which is 4 minus x squared. So I'm going to label this. All right, so this is x comma f of x, which can be written as x comma 4 minus x squared, which means I can call this 4 minus x squared, and of course this as well. And of course this this width at the top is also 2x. So we basically have our perimeter already now in terms of x. So our model comes right about without even kind of acknowledging the constraint. So let's write our model. So our perimeter, I'll say p of x. Well, it's 2x plus 2x, which is 4x. And it's 4 minus x squared twice. So that's 8 minus 2x squared. We might take a look at our domain. Well, x clearly needs to be positive. I mean, x is this value here. That's determining everything. X needs to be positive, and you know, it can't be bigger than this value. So what's that value? Well, it's when 4 minus x squared crosses the x-axis. That happens at 2. So it looks like from 0 to 2, that's what we're looking for, our critical point. So 0 is less than x and less than 2. And I don't think I need to consider 0 or 2 because I won't have a rectangle. It'll either be infinitely thin or infinitely flat, which wouldn't make, would just have no perimeter. Okay, so now we perform some calculus. P prime of x is equal to 4 minus 4x. That's defined everywhere, so our critical points are when that's equal to 0 or x equals to 1. I'm going to use the second derivative test to show that I have a max, because I know p prime of 1 is equal to 0. And now I need the second derivative. So the second derivative is equal to negative 4, which means p double prime of 1 is also equal to negative 4. That's less than 0. So all this means, right, so the first derivative says that's happening, and a negative second derivative tells us concave down, we've got a max. All right, so I'm confident at x equals 1. That's my critical point that leads to our answer. What is the maximum perimeter? Well, you can just plug 1 back into your perimeter function. So our max perimeter is p of 1, which is 4 times 1 plus 8 minus 2 times 1 squared, which is 4 plus 8 minus 2, which is 10.